Hi everyone, welcome to GED Science class. Today we are going to be talking about balancing chemical equations. It's very important that you do understand how to balance a chemical equation for your GED Science exam because I'm 99% sure that you will have at least one question about balancing chemical equations on that exam. So let's start out with the basics. First of all, the reason that a chemical equation needs to be balanced has to do with the law of conservation of mass. The law of conservation of mass states that in a chemical reaction, mass is neither created nor destroyed. It is only changed. So if we look at this chemical equation here, you can see that I have an arrow here. The molecules on the left side of the arrow are called the reactants. The molecules on the right side of the arrow are called the products. So notice that I have the same types of atoms on the left side as I do on the right side. I have hydrogen atoms on the left side, oxygen atoms on the left side, hydrogen and oxygen atoms on the right side. That has to do with the law of conservation of mass. We have not created or destroyed any atoms. We've just changed them. There's still hydrogen and oxygen atoms. They are just in a new molecule, a new molecular structure, a new substance. All right, so some basic terminology for chemical equations. The big number, the uppercase number in front of the molecule, applies to all of the atoms in the molecule, and this is called the coefficient. So here, this number 2 applies to all of the atoms in this molecule, the hydrogen and the oxygen atoms. The lowercase number, the little number after the symbol, applies only to the atom to the left of the number, and this is called the subscript. So the little number only applies to the atom in front of it. So this 2 only applies to the oxygen. This 2 only applies to the hydrogen. This big 2, the coefficient, applies to the hydrogen and the oxygen. So this is really important. Another thing that you should know about the GED exam is that sometimes they require you in the GED exam to write a 1 in front of a molecule when there's only one of them. Now, normally you wouldn't do this. Normally it's understood that if there is no number in front of or after the symbol for an atom, that is just understood to be 1. But for some reason, on some of the GED exams, I've heard that you do have to write a 1. So in other words, what they might do is they might put a line in front of each of the molecules, and you would write your 2 here, your 1 here, and your 2 here. But just be aware that normally, like if you're going into a college class or another science class, you would not have to write that 1 there. It's understood to be 1. Okay, so let's talk about what the coefficients and the subscripts mean. So the subscript, the little number, that means this 2 means there are 2 hydrogens in this molecule. All right, so each molecule has 2 hydrogens, 1, 2. So what does this big number mean, the coefficient? That means there are 2 H2 molecules. So each molecule has 2 hydrogens, 1, 2, and there are 2 total of the H2 molecules. So 1, 2, and 1, 2. So there are 2 ways to look at it. You can either think of it as 2 times 2 equals 4 hydrogen atoms, so a total of 4 atoms, or 2 molecules of 2 hydrogens each, 1, 2, and 1, 2. Either way, you come up with the same number. All right, let's go over here. There's no coefficient, no number in front, so it's understood that there's just one O2 molecule here. So this 2 means I have 2 oxygen atoms, 1, 2, and there's only one molecule. Now over here, this molecule H2O, that's water. Everyone does need to know what the chemical formula for water is, and it's H2O. All right, so this 2 means there are 2 hydrogen atoms in a molecule of water and 1 oxygen atom. Because there's no number after it, that means there are 1. So this coefficient tells me that there are 2 total H2O molecules. So 2 times 2 tells me that there are a total of 4 hydrogen atoms here. 1, 2, 3, 4. And 2 times 1 oxygen atoms means there are a total of 2. 2 times 1 is 2. 1, 2 oxygen atoms. So again, you can think of it as 2 H2O molecules. Here's 1 H2O molecule. Here's the second H2O molecule. Or you can just think of it as 2 times 2 hydrogens equals 4. 1, 2, 3, 4. 2 times 1 oxygen atoms equals 2. 1, 2. All right, let's move on to the next slide. All right, so here I have an unbalanced chemical equation. N2 plus H2 produces, the arrow means produces, NH3. All right, so this is how I like to set up my chemical equations when I'm balancing them. I put down each symbol on both sides, and then I figure out how many atoms there are in each one and see if it's balanced or not. So this little 2 here tells me there are 2 nitrogen atoms here, so I write a 2 here. This 2 here tells me there's 2 hydrogen atoms, so I write a 2 here next to the H. So 2 nitrogens, 2 hydrogens. Now I go to the other side, to the products side of my chemical equation. This N doesn't have any number after it. That means it's understood that it is just 1 nitrogen. This little 3 here after my hydrogen tells me there are 3 hydrogen atoms. So I've got 2 nitrogens on the reactant side and only 1 nitrogen on the product side. I have 2 hydrogens on the reactant side and 3 on the product side. So this is definitely not balanced. So what can we do about it? All right, so first of all, when you are balancing chemical equations, you can never change your subscripts. The little numbers cannot be changed. The only thing that you can do to balance a chemical equation is to add a coefficient. Cannot change, you cannot add or take away subscripts. Those have to stay the same. The reason for that is this subscript, this little number here, tells me what the substance is. If I change this from a 2 to say a 3, it is no longer the same substance. So for instance, H2O is water, H3O is not water. We can't change it to a new substance. We can just add molecules. All right, so how are we going to fix this? I need to have, looking back at this again, I need to have balanced chemical equation where I have the same number of nitrogens on this side as this side, same number of hydrogens on both sides. All right, so what I am thinking here is if I put a 3 in front of this H2, that means I have 3 times 2, 6 hydrogen atoms total. 3 times 2 equals 6. 1, 2, 3, 4, 5, 6. That means I also need to have 6 hydrogens over here, hydrogen atoms. I have 3 in this molecule, 3 hydrogen atoms in the molecule. The only thing I can do is add molecules. 2 times 3 equals 6. So 1, 2, 3, 4, 5, 6. And I already had 2 nitrogens here, 1, 2. This 2 here tells me I have 2 times 1 nitrogen here, which equals 2, 1, 2. So again, because there's no number after my nitrogen, that's understood to be 1. 2 times 1 is 2. Okay, or we can think of it as 3 H2 molecules or 2 NH3 molecules. Here's one of the molecules, here's the second molecule. 1 molecule, 2 molecules, 3 molecules. All right, let's look at another one. Okay, here I've got CH4 plus O2 produces CO2 plus H2O. So again, reactant side on the left, product side on the right. And I'm going to go ahead and put all of my symbols on both sides and count out what I have. All right, so there's no number after this carbon. That means I have 1 carbon. It's understood to be 1. I have 4 hydrogens. This little subscript tells me there's 4 hydrogens. 4 hydrogens. And then there are 2 oxygens here. 2 oxygens. Then I'm going to go over to the right side. I have 1 carbon. 2 oxygens here, but also 1 oxygen here. I'm looking for my total number of atoms for each element on the right side. So 2 plus 1 equals 3. So I have 3 oxygen atoms in my product side. And then this little 2 here tells me I have 2 hydrogens over here. So looking at my equation, my carbons are fine. I have 1 carbon here, 1 carbon here, but I have 2 extra hydrogens on the reactant side, and I have 1 extra oxygen on the product side. So this equation is definitely not balanced. So what can we do to balance it? Okay. So what I need to do is add molecules. Again, I can't change the little numbers, can't change the subscripts. So what I do is I try to figure out what is the simplest, the easiest, most straightforward way to fix it. And sometimes you're going to fix one problem, end up with a new one, and have to fix it again. So just because you fixed just because you figured out how to get the right number of oxygens doesn't necessarily mean you're finished. You might have to change it again. So just remember that when you're balancing chemical equations. Okay, so let's just think about it this way. I've got 4 hydrogens over here. I can't take away any hydrogens, so I know I have to add hydrogens over here. I have to add molecules because I can't get rid of any of these. If I change it from CH4, it's no longer the same molecule. I can't take any of these hydrogen atoms away. I can only add them over here. So let's start there. If I have 4 hydrogens over here, I need to have 4 hydrogens over here. How do I get 4 hydrogens? I add another molecule. Okay, so before it was just H2O. So if I put a 2 here and have 2 H2Os, 2 times 2 equals 4. So now I've got 4 hydrogens here and 4 hydrogens here. Now my oxygens still were not correct. I had before 2 here and 1 here for 3 oxygens, and I only had 2 oxygens over here. All right, but to fix my hydrogens, I had to put a 2 here. This 2 applies to everything, all of the atoms in this molecule, remember. Your molecules are split up or separated by a plus sign or by an arrow. So this is a molecule, this is a molecule, this is a molecule, and this is a molecule. So I have 2 times 2, 4 hydrogens, 2 times 1, 2 oxygens plus 2 oxygens here. 2 times 2, 2 oxygens plus 2 oxygens for a total of 4 oxygens. So now I have to add another oxygen or O2 molecule over here Because if I have 4 over here and only 2 over here, this isn't balanced. So how do I get 4 oxygen atoms on this side? I add another O2 molecule. I put a 2 here. 2 times 2 equals 4. That means I have 4 oxygens. So now I have 1 carbon, 1 carbon. I have 4 hydrogens. 2 times 2, 4 hydrogens. And then I have 2 times 2, 4 oxygens. 2 oxygens here, 2 times 1, 2 oxygens here. Everything is balanced now. All right, let's go ahead and do the last one. All right, I have sodium plus H2O produces NaOH plus H2. One thing I should point out is if you have a capital letter and a lowercase letter next to each other, that means this is one symbol. Na is the symbol for sodium. If you have a capital letter next to another capital letter, that means these are two separate elements. This is oxygen and this is hydrogen. So again, if it's capital letter and a lowercase letter, Na, it's all together as one symbol. If they're two separate capital letters, they're two separate symbols. So that's also very important. Another thing that I should mention is that sometimes it makes sense what the symbols are, H for hydrogen, O for oxygen. Sometimes with Na for sodium, it doesn't seem to make sense, but that's because a lot of these elements way back in the day were based on Latin terminology. So for the English language, it doesn't make sense, but when they were coming up with these elements a long time ago and they based them on Latin, then it did make sense. Okay, let's start out with putting our symbols here and figuring out how many atoms of each element we have on the reactant side on the left and the product side. Okay, sodium, I've got 1 sodium. Hydrogens, I have 2 hydrogens. Oxygens, I have 1 oxygen. Over on this side, 1 sodium, 1 oxygen, but I have 2 hydrogens here and 1 hydrogen here. So 2 plus 1 is 3. All right, so my sodiums match up and my oxygens match up, but my problem here are the hydrogens. So if I have 3 on this side, that means I have to add on this side because again, I can't take away anything. You can't create or destroy matter, only change it. So I can only add a molecule here. So I know that I have to add hydrogens over here on this side. So let's think about that. If I have 2 over here, 1 here for a total of 3, but only 2 here, well, what's the only thing I can do? Let's start out by thinking, well, let's put a 2 here, right? Let's see what happens. Okay, if I put a 2 right here, that means right here, 2 times 2 is 4. That means I have 4 hydrogens over here, but I only have 3 over here. So now what do I do? That's not going to work either. So let's check out what else we try to do. All right, so we put a 2 coefficient here, and that applies to everything in this molecule. 2 times 2 is 4. That means there's 4 hydrogens. 2 times 1 is 2. That means there are 2 oxygens. So I still haven't figured out my hydrogens because I have 4 here, and now I only have 2, 3 over here. And by putting this 2 here, it messed up my oxygens because then now I have 2 oxygens here. And before I put this here, I only had 1 oxygen. So how can I fix this? Well, I'm going to try putting a 2 here and see what happens. Now remember, this 2 applies to everything in the molecule. So 2 times 1 for my sodiums gives me 2 sodiums. 2 times 1 for my oxygens gives me 2 oxygens. 2 times 1 for my hydrogens gives me 2 hydrogens here and 2 hydrogens here. 2 plus 2 equals 4. All right, so then I have a problem because now I have 2 sodiums over here, but until I put this 2 here, I only had 1 sodium over here. So I had to put a 2 here as well. 2 times 1 equals 2. All right, so now as long as I have a 2 here as a coefficient, a 2 here as a coefficient, and a 2 here as a coefficient, now my equation is balanced. I don't need to put any coefficients here, right? 2 times 1 equals 2, 2 sodiums. 2 times 2 equals 4, 4 hydrogens. 2 times 1 equals 2, 2 oxygens. Then moving over here, 2 times 1 sodium gives me 2 sodiums. 2 times 1 oxygen gives me 2 oxygens. 2 times 1 hydrogen gives me 2 hydrogens here. And I have 2 hydrogens here. 2 plus 2 equals 4. So everything is balanced. Okay, so that covers everything for balancing chemical equations. I would definitely make sure that you understand how to balance chemical equations before you try taking the GED science exam. There are practice problems, worksheets, quizzes in the chemistry and matter part in your Google Classroom as part of my GED online science course. So I would definitely do some of those practice problems. Thank you for joining me for class today, and I will see you next time.